Do you know how much water you just drank by asking AI to summarize this video? What if I told you that every time you ask an AI to write an email, plan a trip, summarize a paper, or generate a cute cat image, something very real happens far away from your screen? Thousands of miles away in a windowless building in a place like Mesa, Arizona, or Council Bluffs, Iowa, a machine just took a drink. Not in the cloud, not in cyberspace, but in the ground. Right now, as you are watching this video, massive computers are running non-stop to power AI intelligence. They are solving equations, predicting words, and generating images at an incredible speed. And while they do that, they heat up fast, really fast. To cool them down, those machines rely on something far older than technology itself: water. Not metaphorical water, not digital water. Actual fresh water pumped from rivers, reservoirs, and underground aquifers that real people depend on to drink and to farm or survive. This is the story of AI's invisible test and why the future of intelligence may quietly collide with the future of water. In 2026, we talk about AI like it lives in the cloud, but the cloud isn't made up of vapor, it's made up of steel, silicon, and increasingly your town's drinking water. A single 100-word prompt, that's about 5 drops of water. And it doesn't sound much to you? Well, by 2027, AI's global water demand is projected to hit 6.6 billion cubic meters. That is more water than the entire nation of Denmark uses in a year. Let's start with a simple question. Why is a software thirsty? The answer is heat. Modern AI systems run on specialized computer chips designed to perform billions of calculations per second. These chips are incredibly powerful, and modern AI chips like NVIDIA H100s and H200s are packed so tightly with transmitters that generate enormous heat density. When they operate at full capacity, temperatures can rise fast enough to permanently damage the hardware. If they aren't cooled down, they don't slow down, they melt. So data centers, the buildings that house these machines must cool them down constantly. There are two ways to do this. The first is air cooling, which uses fans and electricity. The second is water-based cooling, which relies on evaporation. Water cooling is popular because it's efficient and relatively cheap. Many data centers circulate water through cooling systems, where heat causes some of the water to evaporate, pulling heat away from the machines. But here is the fact most people miss. 80% of that water is lost to the atmosphere. It doesn't go back into the pipes, it's gone. Traditional data centers like those running emails or video streaming already use a lot of water, but AI changes the scale. AI servers are high density, meaning they generate far more heat per square meter than traditional cloud services, and hence they need more water. Training large AI models requires thousands of high-performance processors running simultaneously for weeks or even months. These chips are packed closely together, generating far more heat per square meter than older servers. That means we will require more cooling, then more evaporation, and there will be more water loss. In fact, a single large AI-focused data center can gulp down 3 to 5 million gallons per day during peak operation. To put that in perspective, that's comparable to a daily water use of a city of over 50,000 people. And unlike households, data centers don't take showers or water lawns. They consume water almost entirely for cooling, much of which is permanently removed from the local water system. Here is where things get complicated. Data centers aren't built randomly. They are built where land is cheap, energy is available, and taxes are low. That means dry places. Many major data centers are located in regions already facing water stress, part of the American Southwest, Central US, Southern Europe, and other semi-arid zones. These are areas where cities are already asking residents to conserve water. Farmers are drilling deeper wells and rivers are running lower each year. When a large data center moves in, it doesn't just add another customer to the water system, it becomes one of the largest users. And unlike agriculture or households, data centers often operate around the clock, with demand peaking during heat waves, exactly when water is scarcest. This is where it gets political. Big tech is currently in a land grab for water rights. In 2025, we saw residents in Uruguay successfully hot a Google data center because they were in a record drought. They said, "We won't sacrifice our drinking water for your search results." In 2026, the battle has moved to the US Southwest. States like Arizona are becoming data center hubs while simultaneously facing extreme drought. It's a paradox. The industry powering the future is draining the very basins that sustain people living there. And follow the money. Tech giants are now some of the biggest lobbyists in state capitals, fighting for confidentiality on how much water they actually use. Why? Because in a world of water scarcity, transparency is a nightmare. Much of this water doesn't come from rivers you can see. It comes from underground aquifers, and that's a vast reserve of fresh water stored in rocks and soil. In hydrology, when a high volume pump like a data center's intake system draws water from underground aquifers faster than it can naturally recharge, the water table drops and it creates what scientists call a cone of depression. Imagine a thick milkshake. If you suck through the straw really hard, the level of the shake dips down right around your straw, while the rest of the cup stays high. In real world, the straw is the data center and the milkshake is the town's groundwater. Imagine your town's water supply is a communal pool. Every resident has a small straw. Then a $1 trillion company moves in next door and drops a fire hose into the center. They tell you they are innovating, but your straw starts sucking air and your garden turns brown. Then you realize that the cloud isn't in the sky, it's underneath your feet and it's being sucked dry 5 drops at a time. When a data center's straw creates that cone of depression, it can cause neighboring residential wells to go dry, even if they haven't increased their usage at all. In many states, right to pump laws mean whoever has the deepest straw wins. Because tech giants can afford to drill deeper than local farmer or a family, they effectively starve the surrounding land of water without ever touching the neighbor's property. At the exact moment, the community is being told to conserve water for their gardens and showers because of the heat. The data center straw is sucking at a maximum capacity to keep the AI from overheating. The result is quiet competition, without fences, without borders, but real consequences. You might be sitting in a rainy London cafe using a chatbot, but your digital footprint is physically manifesting as a water withdrawal in a drought-stricken desert like Mesa, like Arizona or the Sahels. You are essentially exporting the desert water to your screen in real time. The real tech solution? Immersion cooling. Imagine dunking an entire server into a tank of specialized oil. No evaporation, 90% less water usage, but it's expensive. And as long as water is cheaper than electricity, most companies will keep using the soda straw method. In places like Council Bluffs, Iowa, Google facility alone used over 1 billion gallons in 2024. That's enough to supply the entire residential population of Iowa for 5 good days. During the heat wave, the power grid is under stress. To avoid crashing the grid, data centers often switch to 100% water cooling. And the machine is not just drinking the water, it's also poisoning. Even the water that doesn't evaporate isn't always harmless. This leftover water is often a toxic brine. That is, the cooling systems concentrate minerals, the salts, and the chemical additives used to prevent corrosion and bacterial growth. This leftover liquid, often called blowdown, must be disposed of. Some cities can treat it safely, but many towns aren't equipped to treat this industrial soup, so they often dump back into the local water. When improperly managed, this concentrated wastewater can return to local systems, increasing soil salinity, harming crops, and placing additional strain on already stressed treatment infrastructure. So, the impact of AI data centers isn't just about how much water is used, but how much water quality changes after use. Tech companies are promising to be water positive, restoring more water than they use. But restoring often means funding a project 100 miles away. That doesn't help the local community whose wells are running dry today. So, is there a way out? Tech companies are aware of this issue. Many have pledged to become water positive by 2030, meaning they promise to restore more water than they consume. But water doesn't work like carbon emission. Carbon is a global problem, and that is a ton of CO2 in London is the same as a ton of CO2 in Phoenix. Water is local. You can't offset water taken from a dry Iowa basin or from the Sahel, from an arid area, to planting trees in the Congo rainforest. The community losing water today doesn't benefit from conservation somewhere else. Some companies are experimenting with advanced cooling systems, including immersion cooling, where servers are submerged in specialized liquids that doesn't evaporate like water. These systems dramatically reduce water use, but they are expensive. And as long as water remains cheaper than electricity in many regions, companies face a clear economic incentive to continue using the evaporative cooling. Artificial intelligence isn't going away, and it shouldn't. AI has the potential to improve education, it can improve healthcare, research, and communication around the world, and it's already doing that. But it isn't weightless, it isn't invisible. Every digital interaction is anchored to a physical system: energy, minerals, land, water. It is an industrial process. Every time you chat, you are participating in a global resource struggle. The next time you see a headline about a new AI model, don't just ask what it can do, ask where is it drinking from. And again, the next time you use AI, don't just think about speed or convenience. Ask a deeper question. Where is this intelligence coming from? And what is it costing the place it lives? Because the cloud isn't floating above us. It is built into the ground beneath someone's feet. And every time we click generate, it takes another quiet sip. If this video opened your eyes, hit on the like button so that the algorithm can show it to more people. And also subscribe for evidence-based content, and see you in the next video.